this is the debate, and the solution that most people have been advancing is, oh, cut back, cut back, cut back. I'm telling you that yes, respect for nature is needed, and you should look at your own consumption quite a bit, but there's no need to be desperate about it. We can actually solve the real problem, which is heating temporarily. And when things have grown, the forests have grown. Ultimately, if you want to reverse global warming at the same rate at which it is happening today, if you want global cooling at the same rate, so it's extreme. And remember that you can only benefit in the daytime. So you had to have half your system not doing anything that's on the night time of Earth. If you do this, we have to have between 3 and 6% of the Earth's surface area covered. And the difference is because, either you can be unthinking and just do a uniform distribution, which doesn't make any sense, or you can be much more efficient. Namaste, I'm Narayanan Komarath. In July of 2019, which seems a long time back now, I was assisted by the India-US Science and Technology Forum, the Takshashila Institute, and the India Awareness Foundation in the USA, and the Indian Institute of Technology, Madras in Chennai, and many other generous people to organize and conduct the first Abdul Kalam conference. This was to present a roadmap for sustainable growth at sustainable cost, focused on India, but expanded to the whole world. Today, I am building on that, and I'm very honored to be on Sangam Talks. Frankly, I'm a bit scared too. So, I have published a book on this. It's available at Amazon worldwide. I'm going to sort of tell you what's on there. Climate change is in the news. It sort of dominates the news, and it's all usually bad news. Uh, Accusations and disagreements, talk of a tipping point, a point of no return, extreme weather events, drowning cities, mass starvation, species extinctions, wars over water, desperate measures. I'm here to tell you that we can and will win this in time and at a sustainable cost, safely, under total control. And there is no need really to settle for less. So, welcome to the glitter belt. Just out of to satisfy your curiosity, we call this the glitter belt because this is all that anybody will see once it is deployed. You're not going to see huge shadows on the ground or anything in the sky from down below. Nothing in the sky from down below, unless there are navigation lights used at night, which I don't think are necessary either. But from space, you may see a lot of what President Bush used to call 1,000 points of light. In this case, it may be millions of points of light reflecting from down below. That's all that is going to be seen here. So let me now take you to, so that we can get oriented to looking down on Earth from up there. So imagine that you are on the space shuttle Discovery, I believe, back in September 1994, and you are flying over Papua New Guinea, which is 6 degrees south of the equator, uh, somewhat north of Australia. You are about 330 kilometers above the Earth's surface. That's far up in space, but you need to be that high to fly in space, and you're flying at about 7.5 kilometers an hour, or 7,500 meters per second, around 29,000 kilometers per hour. What you see down below is the eruption of the volcano on Rabaul. The volcano used to be about a kilometer high before the eruption. The city of Rabaul was destroyed that day. Nobody was killed because they had evacuated, and thanks to good predictions, I suppose. There is a wind blowing, which is why you can see the eruption so clearly for an instant as the space shuttle went by. The clouds that sunny day are actually way down below at no higher than maybe 5,000 feet, or maybe at most 10,000 feet. about 3 kilometers. And if you look inside the red circle, you can see the black plume rising from the volcano. But it reaches way up into the stratosphere and then flattens out. It cannot go any higher. And the cloud top is brilliant white. Why is that? That is because of water droplets and sulfuric acid droplets in the cloud that are scattering light and actually reflecting light strongly into space where you are. That is why you are seeing it. But down below, you can see deep shadow, not total darkness, but deep shadow. And I bet it's not nearly as pretty from down there. It probably looks like this. Now, back in April 1815, this picture of the eruption is not from there. They did not have cameras there. Mount Tambora in Indonesia exploded. It ejected 160 cubic kilometers of material into the sky. 160 cubic kilometers of material into the sky. That cloud also drifted with the wind, and it reached all the way to in the northern hemisphere to the United Kingdom, which is thousands of miles away. And it is described as a year without summer. They went from early spring in April straight through, stayed cold all the way to the next winter. Crops failed. People starved. There were reports of the population of Wales leaving their homes and villages and wandering in search of food to the cities. So this is a lesson that yes, sharply reducing sunlight will certainly cool the earth. We are not proposing anything like this, let me assure you. By the way, I think that picture on the right is the top of Tambora crater today. The top 1 mile of it blew off. But it is useful to remember that such things can happen quite suddenly, with some warning maybe, but nothing we can do about it. Earth's average temperature has fluctuated over the millennia. If you look back over the past 800,000 years, which is still kind of short compared to the 4 billion or whatever years of Earth's existence, it has gone up and down. The average has only gone up and down by about 12 degrees, about 8 or 9 degrees below where we are today, and maybe 5 degrees above where we are today. So maybe 14 degrees in total. But that is all the difference between ice ages and warming eras. Now, if you look on the right, I hope you can see that the red ellipse is where we are today, and the temperature is certainly going up. And if you look at that expanded on the graph below, you can see that it's going up at a rate that is also going up over the past 1500 years, and we are well above that. So that is, in a nutshell, global warming. Earth's heat balance is a pretty robust balance between the heat coming in and the heat going out, and the heat that is converted to other things, maybe work, let us call it work for now. And that is net heat retention. And today, net heat retention is not zero. So we are not at equilibrium. It's rising at 3 watts per square meter of Earth's surface. Day or night. I mean, it's the Earth's surface as in the whole thing. So that is a pretty high rate, and that rate is rising. And that's the bigger problem. So people are really worried about it. Let's look at that a little bit. All of it, most of the heat comes from the sun, of course. A little bit comes from inside because we do have a nuclear power source down below us. Geothermal energy is there. And we are also digging up some of the fossil buried things and burning it. And that's, of course, putting heat into the atmosphere. So sunlight is coming down every day pretty reliably. And when it's night for us, it's on the other side. 1,367 watts per square meter. Pretty reliable and steady. Out of that, 8% is ultraviolet, and that is absorbed by the upper atmosphere, thankfully, because it could kill us. 50% is visible. So our eyes are evolved to see that and be sensitive to that. 42% is infrared. And that infrared passes straight through the atmosphere. The visible part actually scatters, which is why you see the sky as blue and whatever other colors. The infrared passes straight through, comes down. We can feel it. We cannot see it as heat. The earth can also feel it. And the earth absorbs it, oceans absorb it, land absorbs it, and radiates it back to stay at equilibrium. And it should rise right back into space because oxygen and nitrogen do not absorb infrared. However, carbon dioxide and other so-called greenhouse gases, and I think water vapor absorbs it to some extent, absorb the the infrared radiation quite strongly. That is a problem. So heat hangs around mostly in the lower atmosphere, but it's then heats up the whole atmosphere. So this is the balance. So this is why people are so worried about these greenhouse gas emissions. Now, this is not a new finding. Even anthropogenic, which is a human generated global warming, is not a new finding. Back in 1932, the US Naval Research Laboratory, which is near Washington, D.C., published quantitative data that shows that urban emissions of carbon dioxide and industrial emissions of carbon dioxide were actually increasing the temperature. Around the early 1950s, Gilbert Plas, who worked at the Johns Hopkins University, published what is called the natural carbon dioxide cycle theory. Now, I've looked at those papers, but I read more the Scientific American version of it, published in 1956. Here's the nutshell that I learned from it. Oceans, which are salt water, absorb and store CO2. That is the biggest reservoir, if you will, of carbon dioxide on Earth. Fresh water and ice do not do this, hardly any. Trees love carbon dioxide. They thrive on it. When there's more carbon dioxide, trees grow very happily, and they keep the carbon in the form of hydrocarbons, which is food, and release the oxygen. So trees are wonderful in that respect. Now, when there is warming, there are more trees growing, and the ocean absorbs the carbon dioxide, so there's more heat is radiated because the carbon dioxide is lessened. The planet cools. In an ice age, much more of the water is trapped as freshwater ice on land. So the ocean level comes down. It releases carbon dioxide, and so the planet warms back up again. So this is the natural balance. Now, anthropogenic heat and carbon dioxide emission has distorted this balance. It's going to come to equilibrium, I suppose, if we don't keep increasing these emissions, but that we may not like where it comes to equilibrium. So what is the solution? It's very obvious. Grow more trees, reforestation. But that takes 30 years, and we may not have 30 years. So what changed in all this? Until 300 years ago, most of work done on Earth was by animals and humans and insects, I suppose, everything, or living life forms and things like that. But then we invented the heat engine. So heat engine is something that takes in heat, and people quickly found out that the higher the temperature that comes in, the better the efficiency. So they started looking for fuels that would generate more and more high temperatures. Wood was okay to begin with to generate steam engines. And then they said coal is a lot better. So they went to coal. Then they discovered the petroleum, and that produces much higher temperatures. That heat is converted to work, but not all of it. In fact, not even 50% of it. Our best heat engines can only be 50% efficient. So why can't we just make those more efficient? Well, the laws of thermodynamics put a damper on that. They give strict limits. We can calculate those. So we are really pushing it to get to 50% efficiency. Most heat engines today use, for the reasons I said, fuels that contain carbon, and they use combustion. So that emits carbon dioxide. And other processes that we are doing, which we'll talk about, emit methane in large quantities. And so does rotting vegetation, herds of animals, we emit carbon dioxide. Thawing tundra is a serious problem today. All of these emit methane. Why am I so interested in methane? Methane is lighter than carbon dioxide, so it'll eventually rise or decompose and all this. But in the short term, it is 72 to 80 times as bad as carbon dioxide per unit mass. 72 to 80 times. Take the number 76 times. This is why people are so worried about methane. So, atmospheric carbon dioxide has also fluctuated through the ages. This is a scale of around 400 to 500,000 years, and it has gone up and down. But right now, there is no doubt that it is increasing. And if you believe the observatory results from Mauna Loa, which is in Hawaii volcano, observatory located up there, it is rising so sharply that it seems to be going straight up. That's the reason, another huge reason for concern. What are some signs of this? The northern sea ice, mind you, sea ice, not the ice cap on Greenland and places like that. I'm talking about the ice on the surface of the ocean. That has decreased dramatically. And you can see this from 1850s, when people could not go through those regions at all, down to 2013, which is the latest data. That sea ice has come so far down. Now, this is more complicated than it looks. Everything here is more complicated than it looks. And some really knowledgeable people on climate science corrected my ignorance on that to some extent. They have a long way to go in that, I can assure you. But they said, look, Antarctica is actually not warming. If anything, the ice in Antarctica is increasing. Although ice breaking of Antarctica makes big news from time to time. The Southern Ocean is really not warming much at all. But the Northern Ocean, the Arctic Ocean, is warming. And that is a very scary thing. All that ice may suddenly disappear. And it is apparently, you see these news articles that say sea ice disappearance is accelerating much beyond what was predicted. So because of these things, sea level is definitely rising few millimeters a year, but that rate is again going up very rapidly. What has happened over the years? Well, if you go back 22,000 years, the sea level was 125 meters down below where we are today. If you go back 10,000 years, it was still around 40 meters to 50 meters below where we are today. And for those of us who are interested in looking at what our Puranas say about life long ago, what our ancestors were seeing, you can see that there is a lot of sense there. The sea level was indeed a lot lower. So you can see why Dwaraka is now offshore and under the ocean. Mahabalipuram, if you go out into the ocean, as happened after the tsunami, you can see a lot of temples built down there, which is now under the ocean. So, yeah, this is true. But it looks to have flattened, but it's still rising a little bit. We don't know how far we can go. And I'll show you later that this is a scary thing. So, why do we care so much about a few millimeters of sea level rise? Well, it may not be a few millimeters after some time. And most of our human development is near water sources, mostly near the oceans, some around the Great Lakes. So this is why there is a very strong cause for concern about this. The signs of sea level rise are very visible, for example, at South India. And I don't want to talk more about that here now. So the nations are really worried. And that is where the controversy starts. The developed nations, the industrialized nations, are saying, hey, we have the data now. Earth is warming. You got to cut back on carbon emissions. Okay, they're really bad. The other nations say, well, and who caused this? Okay, you did with your industrial revolution and wealth generation, much of it stolen from us or looted from us. So you caused the problem, you fix it. We need many more years of development. We can't be asked to cut back on development. Also, the developed nations are telling us to tell others, and India is considered not yet a developed nation. China, people argue quite a lot about whether it is developed or not. But right now, China is not on the list of developed nations. We need coal. We need to burn coal. That's the resource we have. We don't have a lot of oil resources. And you don't really allow us to build nuclear plants even if we could afford it. You can't do much of that. So we need to burn coal. And our people need to burn wood to survive. So don't be bothering us about it. Now, around this kept going for many decades. I remember reading about the North-South debate for a long time. South was the poorer nations, North was the developed industrial nation, so to speak, whatever. United Nations did get together And in 2002 came out with an amazing document. You should really read that, the Kyoto Protocol. It set clear quotas for the industrialized nations to reduce carbon emissions, not heat, carbon emissions. And how were they going to do that? Well, they were going to reduce to the level of 1990 by the year 2035, with quotas starting around 2012. How are they going to do this? Well, they would reduce or increase efficiency of their own processes by science and technology, at which they were very good. But they would also get credit for exporting their expertise and all this, and some money to the less developed nations to reduce their emissions. So most of the emission reduction was actually going to occur in the less developed nations. Well, not most, well, at least a large part, without them paying for it. That was the idea. By 2008, 2009, the large industrialized nations had lost most of their interest in it because they were desperately struggling to save their economies during the economic crisis. So I don't think the Copenhagen meet in led to a whole lot. But the Paris Accords, by the Paris Accords, they were all back and happy and strong, and putting heavy pressure on India and China to join as developed nations and come under the quotas. And of course, India and China pushed back. What did the United States do in all these things? It was very interesting. United Nations was a leader in the science and technology and the discussions leading to the Kyoto Protocol. But when it came right down to, I don't know if US actually signed it or not, but when it actually came to ratifying it, the US Congress refused to do that. Why? I got to tell you that this is an ancient lesson learned by Americans. Don't accept quotas and rules and regulations set by foreign governments. Okay. So as much as we may rail against the US and this and the administrations for hypocrisy, this and that, you got to understand this is a hard learned lesson by people whose ancestors had to leave everything they had and run away across the seas in leaky boats just for freedom. They are not, and most of that was from European or British monarchs. They are not going to accept this very easily. But okay, so the US, India, and China, and a couple of other nations got together and said, we will do what we can do. So they invented this thing called nationally determined contributions. Very important concept. They said, we will do what makes sense to us. And yes, we agree that the earth is warming. We're going to do something about it, but we're not going to take any quotas. Now, something else very interesting happened in that time. Around 2004, if you remember, people were all worried about peak oil. Oil prices are shooting through the roof and we are all going to run out of oil and whatever. You don't hear about that today. Why? Because these nations went heavily into the technology of horizontal drilling at a certain depth below the earth, which allowed them to extract um, from fields that were very expensive to do. So this is called fracking. I think it's something to do with fracturing the earth. So this process releases a lot of methane. This is oil exploration and oil drilling. Releases a lot of methane. How much is a matter of contention? I don't want to get into the middle of that. Most people believe that it releases huge amounts of methane. The oil companies, and I've started seeing papers supporting their point of view, saying, no, that we are not really doing that. That's all fake news, whatever. So anyway, why didn't the other nations object to this and call it hypocrisy? So who were the people doing this? Well, North America, United States and Canada, Europe, United Kingdom. These were the main beneficiaries of the fracking. Well, people didn't complain because they all liked the low oil prices. They weren't really going to complain about it. So here's my question. Why don't they talk about heat release? If global warming is the problem, why is the focus not on heat release? And I hunted for this data. So this map that you see is very recent. It was published in 2019, I believe, in a Japanese journal, but written by Chinese authors. And they show that you can see the title at the bottom, Anthropogenic Heat Release, Estimation of the Global Distribution and the Possible Climate Effect. And you can see it, most of it, the vast majority of it comes from Europe, Western Europe, United Kingdom, the United States, and Japan. And there's some in China and India, and I'm not going to question this. Not the right place to question the data and seeing, is the red blotch in China big enough? Is the red blotch in India too big? There are a bit of other things in other places, but this is the reason, as far as I can tell. It's not fashionable to talk about heat release because that focuses attention on who should be doing the reducing. Another interesting point, the IEEE spectrum, which is a very respected publication, it's not going to get banned by Twitter for fake news. They published a paper citing data from the US Lawrence Livermore National Laboratory that shows that the heat to work conversion efficiency in the United States increased from about 14% in around 1900 all the way to 50% by 1950. But today it stands at 33%. 67% of the heat is being dumped out as waste heat, according to this. I have to believe that. Why? I mean, this was so shocking. Apparently, people got rich and they like air conditioning. Okay, so it's for the sake of the comfort of these people like me. Of course, we all have very large carbon footprints compared to other nations. Now, by my calculation, this I have not seen published anywhere because, again, people don't talk about this. The California fires, wildfires of 2020, and that's just California. There were fires in other states that were maybe not as bad, but quite bad. Just that from 2020, a few months emitted more carbon dioxide and I think more heat and more toxins than what came from all of India in a whole year. And I think this is very avoidable. As an aerospace engineer, I have aerospace solutions, which are not mine. I've read about these things. Why this can be stopped quite without too much trouble with the technology that's coming up. Well, the bottom line is that because of all these things, when climate scientists fly intercontinental to climate science meetings with a huge carbon footprint just from doing that, and give passionate speeches on saying that the whole trouble is because of African mothers cooking with scrap wood and Asian farmers doing slash and burn farming or subsistence farming, and say, look at all the smoke that you're putting out. That does not have a lot of credibility, to put it very mildly. Many years ago, I was teaching a class on this before the run up to the Copenhagen summit. And I made the students download presentations from North America, Europe, South America, Asia, India, China, all these places, all PowerPoint presentations getting ready for that. And I said, compare these things, compare people's point of view. The Africans are really angry, believe it or not, about this. But let's get beyond this. The United Nations has another organization called UNESCO. I think it's an economic, social, cultural organization. They came up with something called the Sustainable Development Goals. Those who watched the presidential campaign in the United States may have seen something called the Green New Deal, which I think comes very largely from this, but with the order reversed and some pretty extreme things there. Climate action is number 13 on their list out of 17 goals. Now, when I saw this, I'm a Malayali. I come from Kerala in India. And every year we have the Onam festival where we celebrate the ideal time in our history. That was when King Mahabali used to rule Kerala and apparently the whole 14 universes or whatever. But so there's a song, Maveli Nadu Vanidum Kalam. I'm not going to subject you to my singing skills there. But if you read the words there, something should strike you. They don't say that the people were rich. This was never part of our traditional goals to just, pursuit of unlimited wealth, consume more and more. This was never part of our culture. And so I looked at these sustainable development goals and no poverty, zero hunger. That sounds a bit, should I call it utopian or should I call it Malayali ideal? But I said I can agree with this, most of this. Okay, so that is a sustainable development goals. They make sense. So I think this and these nationally determined contributions really open the way to what I am going to call nature credits. So instead of carbon credits, which are traded today, and in addition to that, perhaps we should think in terms of nature credits, something that you do that makes sense, that actually helps Mother Nature. So here's a summary of the climate change problem. Climate change has occurred many times on a roughly 100,000 year cycle. The present warming causes alarm. The net heat retention rate is rising. The sea level rise is accelerating. So there's a clash between economic development priorities and climate control. This focus on carbon dioxide and carbon quotas, in my opinion, is too narrow. And I think I have the data to support that opinion. The real issues, after all, the heating of the atmosphere. So these SDGs and the NDCs open the way to establishing what I call nature credits. And I want these established at a micro level. Right now, if you want carbon credits, you probably spend tens of thousands of dollars or hundreds of thousands of dollars qualifying for that and getting certified. So you can only afford this if you're a huge company. You had to bring people from Brussels to certify this. Remember why I said Americans don't really like this subjecting themselves to foreign bureaucracies? I think this should be opened up with Indian technology and Indian EU governance and all these things to everybody to do their share. After all, we believe that every squirrel can contribute to war preparations if necessary in the right cause, and that should be done. So, welcome to part 2 of my presentations. This is much shorter. This is a solution. Solar input, the heat coming from the sun, is after all the biggest it's the elephant in the room or whatever it is. It is by far the biggest player in this whole thing, and we can vary it. So this is the glitter belt solution. And I don't think that cricket ball type earth that you see there, you will not see these things so big from anywhere. In fact, you may not even be able to see anything from space with the solution that I am going to propose. Nothing new will be seen there at all. No disturbance. So I think this is going to be monitored, controlled, removable, restorable, with integrated data acquisition capabilities that are unprecedented in scope and worldwide distribution and time resolution, temporal resolution, and spatial resolution. Our aim is to cut heat retention rate by half by about 2035, which I think you need the preparations initially, and then really scale up to zero out heat retention by 2040, and then if you want reverse it all the way back as far as you want until you start feeling cold. We can do that. We can stop anytime. We will do specific interventions once we are reasonably sure of the data and the climate predictions and things like that. And examples are protecting the sea ice around Antarctica and then the Arctic Ocean and places like that, and maybe get to the Himalayan glaciers and all these things. Our technique is to put very thin, ultra thin reflective sheets of aluminized mylar is one way to do it, or solar sail material, way up there, not in space, but at about 30 kilometers above the ground, at an altitude where, as you see, the sky looks totally black. And you had to look downwards to see the edge of the blue scattering atmosphere. So you can see the sun quite a long time after it has set on the surface and before it rises on the surface. How do you support these sheets? So again, what's the difference? This is not in space. 30 kilometers, there's enough air to do this, but not enough air above it to have absorbed hardly any of the sunlight coming in. So you can reflect back essentially 100% of solar radiation. And these are basically mirrors which have better than 99% reflectivity. If you want to do this in space, and many people have proposed this, but it's you will need to be moving at about 330 kilometers above the Earth, remember? And you will have to be moving at about 7,500 meters per second. Now, energy required to do that is proportional to the square of speed. We need to move only at about 10 meters a second. okay, because we are still in the atmosphere. So this means that if you want to do this in space, you need 675,000 times as much energy per unit mass as what I am proposing. And to cap that, if you try to do this in space, you had to have rockets which burn fuel and dump a lot of mass into the atmosphere, and that causes its own problems. We don't use rocket fuel, we use sunlight. So some of the sunlight is absorbed by the solar cells that we have and used to run propellers to keep these things climbing during the daytime. And during the nighttime, they will glide, but not lose so much altitude that they come down even into the edge of controlled airspace. There are three ways of doing this. One is what I've shown on the left, what I call a flying leaflet. That is a basic element of my architecture. It's aerodynamic. It has a wing with propellers and it pulls the sheet along. Somebody said, oh, it's like Superman pulling a cape. Yes. The other is to spin the sheet around so that it stays stiff by centrifugal stress. And you develop these things which look like quadrotors or frisbees. And the third is to simply use hydrogen balloons to take these things up into the atmosphere. That's appropriate where you want the sheet to stay in one place. So that is aerostatic. Why go to high altitude? Why not do this on the ground? You can do it on the ground, but you need permission from people to use their land to do this, unless except what you are doing on your own property. What you are doing on the ground is only 50% effective because you lose 30% of the sunlight coming in through the atmosphere. It's already absorbed. And you lose 30% of the reflected light going out of the atmosphere because that's also absorbed. So 50% is absorbed if you do this on the ground. And it only works when there are no clouds and you don't see the sun for as long per day. Whereas at 30 kilometers, you'll see the full 1.367 kilowatt per square meter and for a very long duration every day, and 99% of that can be reflected. So the basic element, as I said, is the flying leaflet. So what does this do in round numbers? What effect does this have? Just this thing. So this is 60 meters span by 30 meters size of the sheet when it is deployed. That happens after it reaches up there. The 60-meter span is decided because I want to be able to launch this from a cricket ground or from a Maidan, hopefully no lampposts and things like that there, or from the beach or a hilltop. You don't need airports for this. This thing, this basic element will cancel out the heat that is released by a 2 megawatt power plant because even operating at 50% efficiency or somewhere close to 50% efficiency, it cannot do anything about the carbon dioxide, but it will cancel out the heat release. It does not require airport runways. So the procedure is that on a nice bright summer morning in the northern hemisphere or southern hemisphere, you lift off. The lift-off speed may be around 30 meters a second, which is very easy to reach, and then climb to 8 hours, 10 hours, whatever, to 100,000 feet, 30 kilometers, extend this thing, and then join up. That's the difficult step with 10 more of these things so that you establish what is called a very high aspect ratio wing. That is critical to reduce the glide speed so that you can stay up there all night. And then 8 of the 11 wings that take it up there, which is most of the weight of this, will come down again to repeat the process. So that's what is shown here again. 11 leaflets form a leaf. And so one leaf is about 20,000 square meters of solar reflector. 8 of the 11 wings return to pick up new sheets. And this thing now flies around at about 10 meters a second. The nighttime 12-hour, if you have a 12-hour night, the loss in altitude is less than 5,000 meters. And you also put in a north or southward drift speed of 1 meter per second, even while gliding. This is to stay with the summer sun. In other words, the best place to reflect light is right under the sun at the peak of summer, wherever the sun is right above during summer and wherever it is summer. So you had to move northward and southward every year. Roughly 15 leaves we could form into a swarm like birds. That helps the efficiency a little bit. And it also allows you to monitor each other and operate as a swarm with the minimal controls and communication. You can communicate with and be controlled from global positioning satellites. There are no clouds above. You can see those satellites day and night. So these swarms can stay up indefinitely. And people rightfully ask, hey, why do you think you can do this? Because it's a really big deal to build high altitude, long endurance aircraft, as NASA has been doing and the European Union has been doing. The trick is here. Our payload is these sheets, and 90% of the aerodynamic lift comes from the sheets themselves. That is the trick to making it work, and I think we have mastered that quite well. We don't need any energy storage like batteries, no, maybe very small batteries for control, but not to store energy for flight. And we can do this summer follower, so the night is never longer than 12 hours, which is very interesting. Now you can get smarter because you have three ways of doing it, remember. So you can combine all three concepts, and perhaps you extend the leaf. That's the first thing I would do. The leaflets would now, once they're formed up, they would extend. So each leaf is 50,000 square meters instead of 20,000. And then I would use them as rotor blades around a spinning sheet, very thin spinning sheet, which might itself be 5.5 million square meters or 5.5 square kilometers. So now, what does it take to reach zero heat retention with no other help? The baseline 1800 square meter things, if you have no other help, 1,250 million launches, 1.25 billion launches. That's a lot. If you're smart and use the things that we already have in the works and all these, and and the extended leaflets, just the extended leaflets brings it down to 500 million launches. If you have these rotating sheet things with a total of 5.67 square kilometers each, you only need 1.6 million, but you have to assemble it up there. Yes, these are big numbers, but consider this statistic. In 2019, global motor vehicle production was 92 million per year. And a motor vehicle, believe me, has a huge number of parts and complication compared to our vehicles. How much does it cost to reach global net zero heat retention? Very difficult question, and you should not, as a matter of principle, ever believe a cost estimate put out by the inventor of something. But I'll tell you the most honest answer that I can come up with today. The most basic way of estimating cost is by saying cost goes as proportional to weight in the aerospace industry. So I looked at the cheapest mass-produced example I could find, in Indian automobile. Now, why automobiles? Because automobile production is distributed all around the world. It's not a few big aircraft companies that produce this. And I think this is more suited to that. The cheapest Indian automobile is around 700 kilograms and has a ex-showroom price of $3,800, which includes a markup of actually 100% markup. So 50% of this is markup. So a leaflet, by my calculation, is only 400 kilogram, but let's say 500, that's $1,350. You need 331 million of these. You don't need 1.25 million because 8 out of 11 are going to be brought back and reused many, many times. So that comes out to about $450 billion. And you add a few billion here, billion there, pretty soon it adds up to real money, as the saying goes in the defense industry. So let's say $600 billion. Now, again, a mass-produced leaflet is much simpler than a car, but I don't want to cut my own throat by saying I can do this for $10. I can't. What do you mean? How does this compare with other things? So the best comparison that I can put out today is with the Lawrence Berkeley Labs estimate, and they have published a roadmap this February 21, which I fully expect to be adopted more or less by the new US administration. So they say that net US carbon emission, net zero carbon emission from the US by 2030 is feasible if you invest $1 trillion between now and 2030, $1,000 billion. So compared to that, I'm saying we can reach worldwide net zero heat retention by 2040 by the glitter belt alone, $600 million. $600 billion. What is the difference? Net zero heat retention rate means that global warming is stopped. Net zero carbon emission keeps the US contribution to the net heat retention perhaps at the present, or heat absorption rate at the present level. But I think global warming will continue at more or less the same rate. Only the rate will not increase. Now, any ideas and proposals to do this kind of thing? I know some people may be sitting there sharpening their knives. Geoengineering. It has a very bad name. People say, don't go and mess with nature. Okay, you don't know what you're getting into. And yes, I'm very interested to hear all such concerns because, yes, we need to address those. And so far, I have addressed all such concerns that I know of, that I have heard. When you hear these, of course, steam and smoke comes out of your ears and say, oh my God. And then you think about it and you'll reason it out. And so far, I have been able to rebut or respond to very clearly to all of these concerns. But yes, please, during the discussion or going on, let me know about this. Why do I say that India is the right place to lead with this? I think India should lead nature credits. Of course, it's not for me to tell the Indian government what to do, but we have suggested this with the Abdul Kalam conference, and I'm now much surer of this. Give nature credits to do what is right to heal Mother Nature. That's not geoengineering, that is common sense. Cut air pollution, land pollution, soil pollution, water pollution, and of course, reduce heat input from the sun. And of course, yes, support the glitter belt. Give us nature credits for doing this, because right now carbon credit will not recognize heat reduction, which doesn't make any sense to me. Sequester carbon by all means, grow trees, adopt vertical farming to the extent possible where it makes sense. That actually conserves water, makes farmers a bit independent of the monsoons, vagaries, and all these kind of things. Reduce the area of open fields and increase the area covered by trees. Use biogas. See this, that thing sitting there is in my in-laws' backyard in Thrissur, Kerala, and that is built in Thrissur. Actually, it's Indian technology. It's a constant pressure biogas generator. My in-laws put in vegetable cuttings from their kitchen. I don't know, 3 or 4 people in the house, and that's enough to produce enough biogas so that they have reduced their consumption of cooking gas by 50%. So it actually pays for itself. Why not adopt that on a much larger scale and convert what would have otherwise been methane emission to energy independence? Go to photovoltaics. Of course, India has been doing that on a big scale. Go to fuel cell, hydrogen economy, electric vehicles, all these kind of things. Go to energy independence, which is my dream since I was an first-year undergraduate in 1973 and watched the devastation of the Indian economy by the oil price shooting up from $3 to $11 overnight due to the war in the Middle East. But teleworking, which we have been forced to do, actually contributes. So India is the right place to lead this. And I think the Indian expertise in e-governance, and they've got a billion people, 1.3 billion people used to dealing with things by cell phones. I'm not competent at that. We should be able to get nature credits through the cell phone, smartphone. And here's my very rudimentary cut at how this should be organized. A consortium, the Glitter Belt Consortium, with national governments deciding what makes sense for their people, and coordinating university research from all over the world, but the government's coordinating air traffic control, ATC, communications, nature credits, international issues. Bring in the United Nations, but both the UN Framework Convention on Climate Change, UNFCCC, FCCC, and the UNESCO. Let them deal with the global data aspects of it, global credits, and take it, global from India. Climate science, coordinate that. And commercial operators to do the manufacturing, deployment, data acquisition, monitoring and control, maintenance, recovery, and disposal. How would we go about doing this? Well, beyond the testing phase, which I hope is very short, but I want to point out, every time I do a flight test, including my undergraduates taking something this big and throwing it out there to test it, the glide, we are reflecting sunlight. So every test helps, actually. It reflects sunlight a little bit. But we want to go as quickly as possible to a summer follower sweep from South India to the Antarctic Circle and back. which is the eastern swarm. A summer follower sweep from Hawaii north to the Arctic Circle, south to the Antarctic Circle, and back. That would be the western swarm. And then we'll go to a polar circle, stationary balloon-held sheets or leaf swarms over the edge of the Antarctic ice cap, not actually on top of the Antarctic ice cap. And a polar circle 2, which may be more distributed, stationary and slow-moving balloon-held sheets and leaf swarms over the Arctic ice cap and tundra. To all the people who say, oh, no, we don't want to do this, and let's talk more about it, and to do this and that, I want to point out, and in this I am fully in support of Dr. Greta Thunberg, I believe. Inaction is not an option. There are enough hydrogen atoms and oxygen atoms still on this planet to do what happened 450 million years ago, when the sea level was 400 meters above where it is today. Now that's a scare tactic. Oh, 400 meters. Would you like for it to be only 40 meters rise in sea level? Imagine what that would do. So no, inaction is not an option. We need to get moving. Okay, global climate change is not fake news or anything like this. We got to get moving. But we had to do it in a manner that makes sense to us. As an aerospace engineer, I want to tell you that I solved the problem that I originally set up to do. I said, oh, if it's, I don't know about all this climate change business. They don't really know, the data are so uncertain. So if it's warming, we'll beam the heat out. And if it's cooling, we'll beam the heat in. So if there comes a time down the line where we have grown so much forest and the sea has gone up and all these things, and the earth starts cooling, and you say, oh my goodness, there's not enough carbon dioxide, what are we going to do? Well, you can either set fire to all the forests, which I don't think is a good idea, or you can just reverse the glitter belt sheets so that the reflective side is on the bottom, the absorptive black side is on the top to radiate, and you tilt it so that you catch sunlight that would not otherwise have fallen into the atmosphere and bring it into the atmosphere, help global warming in that respect. So in conclusion, climate change is real and it has terrible consequences. There are much larger swings of climate are actually possible. The focus on carbon dioxide and greenhouse gases is too narrow to recognize Indian or American priorities. And I think those of countries like, continents like Africa, all the countries there are probably with us in this. The glitter belt can reduce and control heat input precisely. And it is one of my role is as a concept developer. I'm not a billionaire. I don't have money to start this tomorrow all by myself and all these kind of things. But usually what I see is that people are very smart, and they're at least as smart as I am. So at least somebody should say, look, one solution has been demonstrated. So we know it can be done. So let's try to see how we can do it better. Do better. Great. I don't want to be under 100 meters of water either. Indian leadership is needed for broad nature credits, including the glitter belt. And that's the way to make this actually pay for itself and more. Reversing heat retention back to 1990 level. Nobody talks about going further back than that to the start of the Industrial Revolution, but it is feasible. The glitter belt can also alleviate natural cooling if it ever becomes necessary. So 2 takeaways. Number 1, the glitter belt will buy time to raise forests and cut emissions and do all the things that make sense for us anyway, that we would do anyway, need to be doing anyway. And we need Indian leadership to establish nature credits, hopefully micro level nature credits, and allow public participation. Thank you. That's all I have. And I'll be happy to start the discussion.
Sir, there are I have 2 questions. So first question is, we always seek for the zero carbon emission. But today we are all-time population high in whole history. Today we are just exploiting, you can say, by eating, many of the people are eating non-veg and all, we can say we are destroying our ecosystem. Yes. So, what is the view of the ecosystem according to it? Because you just included the carbon emission, but we have not addressed that issues of the ecosystem. So, because if we have a zero carbon issue, if we plant trees and all, but there is will be a ecologically unbalanced. Okay, so that is my question. And regarding your glitter bed project, it was very good, but many of the people will talk that what is there in the air. Why we can do it not in?
Thank you. So I want to thank you for supporting and amplifying on what I said in many respects. Yes, I think the sensible thing to do is to do what makes sense to what I call restore Mother Nature. We need to do what makes sense and we need to restore the ecology. Now, some of it I'll tell you. I think population rise. I grew up when people were predicting that India would not last for more than a couple of years. There used to be expert opinions published almost as frequently as global warming, saying India is going to blow up. Malthusian theory of population. That has been pretty much discredited. The reason India is really zooming ahead today is that we have a population, and it is a young population, very dynamic population, and people who believe in India. And I think that has been shown. It's not to say that we need another billion people. No. I kind of reject the discussion of population here. That's not really. I'll tell you that per capita, that's what really matters. Per capita carbon footprint. How much are you contributing to this? If I look at myself, I'm a sinner, so to speak. My carbon footprint, except for this last year, is very high because although I don't eat meat and I'm very careful and etc. etc. and I'm very stingy, so I don't go into heavy consumption. I don't have money for it, but I fly international once a year at least and used to fly on business trips. Just doing that makes my carbon footprint probably around 12 tons of carbon dioxide. Okay, compared to somebody from Africa, and most people in India are at maybe 0.1 tons carbon dioxide footprint. So how can you go, sitting here? I asked somebody in the US this, and of course they didn't get very happy about it. How can you sit here? The Texas is probably the worst offender in this. There's so much cattle being raised just to eat them. And that puts a lot of methane into the air, which is 80 times as bad as carbon dioxide. You drive cars with SUVs giving 3 miles a gallon. And you go and tell somebody out in India to reduce their carbon footprint. They're not going to do that. You are the ones who should cut back. So that's the idea there. But this is the debate, and the solution that most people have been advancing is, cut back, cut back, cut back. I'm telling you that, yes, respect for nature is needed. And, you should look at your own consumption quite a bit. But there's no need to be desperate about it. We can actually solve the real problem, which is heating temporarily. And when things have grown, the forests have grown, that's all right. Now, I don't see what is so bad about growing the forests back. At the very beginning of my talk, I had a picture from space looking down on India. And if you look carefully at that, most of India now shows up as brown, not as green. Why is that? I think most of that used to be covered with forest. I don't think we were doing so badly at that time. So there's no reason why you can't green quite a lot. In fact, the forest cover on Earth can probably be increased by a factor of 3, and that will remove much of this problem. But it will take a long time. So that's really my answer to that. Now, regarding the glitter belt, your reaction is like that of many people. And my answer to that is, okay, so what do you see wrong with that? The answer, what is there in the air? Well, airplanes fly in the air. You can fly in the air, although you are definitely much heavier than air. We're not all full of hot air. So yes, things can be done in the air by using science and engineering, and that's the one thing which I used to get paid to do actually. So yes, I think I know something. I'll be very happy to take any objections you have to the concept, but only objections that are based in science and engineering and common sense, not superstition. Thank you.
First thing is, I just want to know that by installing these sheets, what fraction of the Earth's surface will be in shadow?
I'll tell you the very simple answer to that: zero. Because if we look back at the concept of diffraction that they tried to teach all of us, at least me, very unsuccessfully in the IIT or in high school, if you look at what happens, I'll give you an example. And I think Rajiv asked me this a long time back, and I answered that. Suppose you hold an umbrella close to the ground, you'll see a deep shadow down below. But suppose the same umbrella were held 100 feet above you, will you see the same intensity of shadow? Absolutely not. You'll see hardly anything. The light will fill it because it comes around the edges. It doesn't turn corners, but it scatters off the edges. So it fills up the shadow. So if you put up a sheet, if you put up a huge volcanic cloud at 15 kilometers, yes, you're going to see a shadow, continuous volcanic cloud. But if you put these sheets, which are separated from one from the other, way up, so they have edges all around, and this is 30 kilometers up, you will see absolutely nothing. Okay, you will not be able to see the sheets because it's above the scattering atmosphere, and the undersurface we will have black because we want to absorb nighttime radiation. So you cannot see it against the black sky at all. You don't see stars in the daytime. Why would you see these things? So the answer is zero. Now, I think your question, however, was deeper than that. What percentage of the Earth's surface area do you have to cover? That can be calculated quite easily, and if depending on what you want to do. So ultimately, if you want to reverse global warming at the same rate at which it is happening today, if you want global cooling at the same rate, so this is extreme. And remember that you can only benefit in the daytime, so you had to have half your system not doing anything that's on the night time of Earth. If you do this, we have to have between 3 and 6% of the Earth's surface area covered. And the difference is because, either you can be unthinking and just do a uniform distribution, which doesn't make any sense, or you can be much more efficient. Yes, 3% of Earth's surface area, huge. When I first presented this at an SAE conference back in 2017, the coffee break was just coming up and nobody got up to leave. They just sat there and they looked at it and said, he's proposing to cover 6 or 3% of Earth's surface area. Somebody else said, yeah, and so what's wrong with that? He's shown that why it can be done and what it costs to do it. So that's the answer to it. It sounds extreme, and that's not going to happen tomorrow. You need 1 billion launches or whatever, hundreds of millions of launches to get there. So you'll figure out as you go along and say, no, we don't need to do that because the forests are already coming up, or because President Biden has already closed down all the coal plants, whatever, and you'll decide to stop somewhere else. I hope that answers the question. Thank you very much.
I have another question, which is somewhat tangential to this discussion.
Yes.
So there is a lot of focus on carbon, but
Yes.
why don't we have such a similar intensity of focus on methane, which is obviously more potent? I mean, you can get 20 times the return from methane reduction.
Correct. Because there is so little of methane by comparison, and it is highly distributed. What are you going to do to reduce methane? The best thing to do is stop eating meat, as somebody pointed out. But that's not going to fly very high in places where you don't have much vegetable or things like that, and that is their diet. Okay. So I would support that, but that's me because I don't think I'll get hurt by it. So methane comes from there. Another big source is the tundra is melting. The permafrost is melting, and all the vegetation buried under Siberia and the northern Canadian tundra is now that methane is bubbling up, and there's nothing we can do about it. This is huge areas. So partly that's that, but also methane dissipates. See, methane is, you look at the molecular weight of methane, it's, 16, whereas carbon dioxide is 44. So methane is a lot lighter than carbon dioxide. So it will dissipate and it'll rise a bit and then get blown away. So they don't think it's that harmful. So that's why they say over a 100-year period, methane is only 20 times as bad as carbon dioxide. But in the short term, it is 76 to 80%. I think one should get credit, of course, and you do get credit for reducing methane, mind you, because the carbon credits are for reducing 1 metric ton equivalent of carbon dioxide. So you don't need to reduce 1 ton of methane to get 1 carbon credit. You can reduce much less. So biogas containers producers are very effective at this. But my in-laws don't get any credit for doing that. Why not? Why only the big companies? And that's what I'm asking. So I think, yes, by all means, give people credit for reducing methane. And you'll see that it actually helps a great deal. So thank you again for that question.
My question, frankly speaking, I have not read much about the solution that you have proposed. So I don't think I'm in a position to actually ask you questions on the solution.
I haven't read hardly anything on climate warming, climate change /science. So go ahead, please. Yes.
Right. So I have some simpler questions, and I'm sorry if I'm going to ramble a little bit. So my first question is, this whole talk about global warming. Now, no one can deny that if you have a sensible mind. However, there are times, for example, when we talk about heat release, especially due to forest fire. And there have been cases in Australia, in USA, Florida area, wherein the media projects and says that the forest fire has increased, which means global warming is going up. While they conveniently ignore the fact that the forest department intervenes so much in the nature, wherein they put out the fire when it is starting, because the nature has to take its course. And due to this, somehow the contribution could be due to global warming also, but a lot of it is also because of manual intervention. And what is happening is everyone, starting from politicians to media to activists, they are cherry picking the instances, they are cherry picking the data that suits their narrative and scaring everyone. So, what are your thoughts on that? That's question number one. So, would you like to go one by one? How should we do that?
Please go ahead and ask the whole thing, and I'll ramble on and with my answer on the whole thing. Yes.
Right. And the second question is that, and I'm so sorry if this question may sound little insensitive. How do you think the scientist should be careful about finding solution to sustain life and stop short of interfering with the nature and the environment? Yes. While it is important to find a solution to sustain life, it is also important to understand that nature has to take its own course. Like, for example, the Earth's atmosphere is supposed to get warmer, and it has accelerated, no doubt about that. It has accelerated. So, how do you think the scientific, the whole world is actually handling that, or should handle that?
I think very good questions, of course. Let me take the first one first. And I'll again, apologies, but I'm going to use your question as an example of the continuous debates and things going on. So in the United States, I know there is a very strong debate, depending, and the political parties get into this on opposite sides, on this question of forest fires. If you remember, the President Trump threatened to cut off funding to California to fight forest fires because he said, you're not serious about fighting it, you're doing this. Okay. Here are some statistics on that. So as I said, I tried to calculate the effect of just the California wildfires, which were very bad this year. And I told you that if they had stopped that, that would be equivalent to a whole year's emission from India. So why go and bother India? And this has been continuing for a long time. So I'll give you a very short story. I hope I don't take too much time. Back in 1989, my wife and I took the first vacation that we took. Other things were business trips. So, but we took a 1-week vacation and said, we want to go and see Yellowstone National Park. So we were, of course, poor and stingy. And we bought non-refundable tickets many months ago while they were cheap. and we're all set. That was the year of the worst wildfire in Yellowstone National Park. It's called the Yellowstone Fire of 1989. You can look it up. The entire park burned. And that was a very controversial thing because they said the fire is so bad because you're not allowing natural fires to clear out the underbrush which is growing there. Because you're saying, oh, no, keep that there, and etc., etc. Natural fires used to clear that out, and because it was not there, that whole park burned. Just to tell you the story there, I did not cancel my reservations. I would have lost money. I told my wife, look, don't worry, it rains whenever we go on vacation. But it didn't rain. The worst day of the fire was the day that we flew there. And everybody on the airplane going there was a firefighter. So that's the other side of it. Firefighting is a huge seasonal business in the United States. If you suddenly stop there, a lot of people would get very angry at you, and they would lose their livelihood. Everybody was a firefighter, and we said, oh no, that's all right. We got the rental car and drove 2 hours to wherever West Yellowstone. The sky was getting more and more smoky. There was no traffic on our side of the road. The other side of the road was packed with people evacuating from there and running away. And we just went there, and the hotel was empty. There was a guy sitting there with red eyes, maybe from the smoke or because he was drunk out of desperation. And I said, don't worry, it's going to rain tomorrow. He glared at me. Next morning, there was an inch of snow on the ground. The fire was out. But anyway, back to this. So there's a lot of controversy on how forests should be managed. And apparently, California, according to people that I read, has allowed the density of trees per acre to go up by something, depending on whom you believe, by about a factor of 10 from where it is normally. So this is a case where intense focus on reforestation makes the fire that much worse. I don't know what happened in Australia. I don't know whether the fire is because of global warming. These days, everything is blamed on global warming. I think if the traffic gets bad, they'll say, haha, look at that, global warming. But this is why I took the example of California. It was really bad. But what do you do about this? That's what I said. We got to get to a point where we are doing this in a sensible, sane manner. Now to get to your second question. The first thing that I started worrying about is if you start messing with nature, what happens? But aren't we messing with nature in other ways? Somebody asked me this question, and I said, look, if you look at a picture of Adi Shankara, who actually, I think I come from the same town where he did some of his education, you see somebody holding an umbrella. So holding an umbrella is not interfering with nature, is it? And that's all we are really doing, temporarily. And these umbrellas are not going to be left up in the sky. They are going to be brought down when we don't need it. So there is no permanent interference. We are not doing anything like that. Of course, you have just, I should record your comments and play that to all the people who propose putting up sulfuric acid clouds into the stratosphere to reflect sunlight. There are some very strong proposals like that, which I don't want to criticize them up here, but you can see that there should be concerns about interference in those kinds of things. So yes, you're right. We should think about what we're doing. But okay, so why don't we just do nothing? I told you why. It's not the temperature, it's the sea level. What if the sea level actually rises by a tenth of where it has been before, 40 meters? Would you like to explain to the people in Mumbai or Ernakulam or Chennai why they are underwater? Because we chose not to do anything. So that's the choice. And the islands all over the Indian Ocean and Pacific Ocean, which are going under right now. Thank you.
Ingenious and a wonderful presentation.
Thank you.
And me being an architect, I started looking at some solutions architecturally. And then I just wanted to ask you whether there something like that would work, like when the corporation or the authorities are giving sanctions for the buildings, can they introduce something like nowadays you have, if you're using solar panels for water heating, you do get a 10% reduction in your property tax or something like that. So could we make it compulsory for builders or for houses to cover their roofs, at least, if not the walls? So what you're proposing as a device in the 30 kilometers above, can we have it individually for buildings? And then the thing that you were suggesting, then those buildings who have those things should be given nature credits or reduction in their property tax or something like that. In Goa, we get, if we put solar panels for electricity, we get a subsidy of about 30% or so. So could covering the entire roof with solar panels where you're using the heat so the electrical needs would be reduced, and at the same time the surface would not heat up. Could that be a solution?
So thank you. So yes, by all means, I think the issue is the nature credit. Why am I saying this? See, the Kyoto Protocol is very interesting, and that's why one should read that. The way they resolved this finger pointing north-south debate, whatever it is, was to say, look, we can choose whether to have penalties for, impose a rule and say we're going to penalize you for not following it, or should we give a positive incentive? So they came up, and this is why, this was a very well-intentioned thing. They came up with the idea of carbon credit, that if you do something which is proven scientifically that you've actually done it and recognized, which is why they have the authority in Brussels to certify, then you would be issued so many carbon credits. You can trade those. So they established a carbon market where these would be traded like stocks. So you have a stock certificate for so much like that. You have a certificate that says 1,000 carbon credits. The value of that will fluctuate depending on demand. And they said, look, as we get closer and closer to the 2012 deadline where we start imposing the quotas, governments and companies will be very eager to buy these credits, because otherwise they have to cut back their activities or face a penalty. So they'll be willing to pay more and more money. And I think they established the penalty at about $40 equivalent per ton of carbon dioxide that you were releasing beyond your quota. So they said, look, am I going to pay a penalty of $40 or am I going to buy the carbon credit? Maybe somebody will sell it to me for $35. Then I'll do much better. So they said, look, the free market will determine the value of this thing. We don't want to interfere in that. And this is an incentive system which rewards people for doing this and rewards people for creating such credits. So go and build how do you get these things? You build a wind turbine farm and things like that. So very, very, I should say, far-sighted and enlightened way of doing this. And so I think I recommend this to all people in administration and politics and all these things. I'm sure they know this. Positive incentives work much better than rules which are set up. And then, once you set the rule, you have to have inspectors to go inspect and penalize people, police to go beat them up and all these things. Instead, just make it possible for them to get money, which is exactly why I'm saying broaden that to nature credits. Why only carbon reduction? Okay, recognize anything that reduces heat by doing this, and make it possible for the Aam Aadmi, Aurat, whoever to get this, not just big corporations. This is where India can really play a huge role because you have all these things that are done through the cell phone. I don't think it exists hardly anywhere else. I think the only other place I've heard is East Africa. Kenya does all payments through the cell phone and things like that. A wonderful system to emulate. But yes, we do need this. Now, have people thought about this? So yes, architectural credits are already there for a lot of things which are recognized, and solar, whatever is recognized. So the government is already doing this. But I'm saying, why don't we do this and say, this is how we are going to do it, not just carbon credits. Tell the UNFCCC, this is what we are going to do, okay? And don't be tied into this carbon credit system. That brings a lot more money into the whole system. And frankly, from selfish interest, I think we tried calculating. So who else has proposed this? The United States Federal Labs, I believe Sandia Labs, back some years ago, and the name on that was a Malayali name, Menon, if I remember right, and somebody else, proposed system. So the federal government was clearly looking at this, where you would mandate that sidewalks would be painted reflective white and roofs would be painted reflective white. And they said, okay, how much will this help? So urban heating would be reduced quite a bit. And they created an equivalence between that and carbon credits. I looked at that and said, wow, if they gave me that, I would, we can easily do this glitter belt for that kind of money. So you're right, absolutely on the right track. We need to convince lawmakers on both sides of the world that this is the way to go. Thank you very much.
The other part of my question was the umbrella that you proposed 30 kilometers above the Earth's surface. Can it be for individual buildings? So localized umbrellas, no?
No, for the reasons I said, you will not see the shadow from an individual sheet anywhere. Okay, you will be able to sense with very delicate instruments the amount of heat that has been reduced. Because you have thousands of these things spread out all over, you just won't be able to see it even. Why don't we put this a lot lower? Well, first of all, much more heat will be absorbed on the way up and down. If you come down below about 30,000 feet, the atmosphere is so much denser. So why don't we do this lower than that? Of course, I think about that. I think I could come down to 80,000 feet, maybe. But if you come down to 50,000 feet, you see that volcanic cloud getting blown away by very strong wind. So winds are the problem. Okay, these ultralight sheets are going to get destroyed. So I need to be above the weather. I don't want to get caught in a hurricane or tornado or even a thunderstorm. You have to think about these things. An umbrella that you put up above a building may get blown away. And people will worry about this. See, people flying in airplanes will say, oh, that flash in my eye. Okay, or somebody sitting in a 20th floor apartment will complain, saying that, oh, that roof down there is reflecting into my eye. So you got to worry about all these things.
So my question was, how much one plate would cost? You can say you have given a very good explanation. So what will be the distance from one plate to another plate? You have given the height, but what are the chances of technical error? Means the plates getting fall. And we have seen some places there are no pollution. So what is the chances of that no pollution area will need that plate?
So let me explain that each of these vehicles, however big or small, you should look at it as a drone or a UAV. It's a flight vehicle that is always under control, perhaps autonomous control, perhaps a manual remote control, but under control. So the answer is you can put it wherever you want. How much distance between sheets? It can come very, very close to each other, but you really don't want to do that. You want widespread coverage. You don't want to do anything at a certain point until we know exactly what we are doing. You don't want to cause a large effect. You want the effect to be distributed widely. Also, but since they're under control, you can be smart enough and not go and waste your time blocking the sun in winter. You concentrate on summer and you concentrate on hot areas and things like that, but not you can't do over a certain building and things like that. Chances of error, I am an engineer, remember, and I think the Wright brothers may get a lot of credit for being the first aeronautical engineers. They were not. I don't think they were aeronautical engineers, they were bicycle, but the first aerospace engineer was probably the one who invented the parachute to go with that aircraft, because we always fully expect that things will go wrong. That's why we need testing. And the process of this, and we want to do the testing over the ocean, where if it falls, a few fish may complain, but nobody else. But over time, so the whole challenge here is reduce the uncertainties of all kinds. Keep on reducing uncertainty. And in time, people will say, oh, yeah, you can fly over my territory, no problem. Okay, you notice I showed things going south from India, but not north across India and China and all this. In time, we'll be able to do that when people are sure. Okay, consider that you don't worry that planes are flying over your head, satellites are flying over your head, balloons are flying over your head. Why worry about these things? They're much lighter. Thank you.